Hello students, this is fourth video related to chapter electricity. In this video, we'll discuss about resistance, on what factor resistance depends, and combination in parallel and series of conductors. Resistance and factors on which resistance depends. First of all, in previous video, I have already explained what is resistance. Again, I am giving definition and then we'll discuss on what factors resistance depends. Resistance is a property of a substance which oppose the flow of current. Resistance is a property which not allow the flow of current through a conductor. Resistor is a substance and resistance is a property. Resistance is a property of substance which resists the flow of current through a conductor. Now factors on which resistance depends. First one, length of conductor. Resistance depends on the length of conductor. Resistance depends on area of cross section of conductor. Resistance depends on the nature of material of conductor. Resistance also depends on the temperature. If length of conductor is increased, in that case resistance will also increase. If length of conductor is increased, in that case resistance will also increase. That's why R is directly proportional to the length of conductor. Why length increase, then resistance will increase? Because when length will increase, in that case collision between free electrons and atom of conductor will increase. So because of the increase in collision, resistance will increase. So length of conductor affects the resistance. Resistance is directly proportional to the length. Second factor on which resistance depends is area of cross section. Means when thickness of conductor will increase, it become convenient to travel free electron from one end to another end. So when thickness will increase, area of cross section will increase, resistance will decrease. That's why R is inversely proportional to the area of cross section. First one, R proportional to L. Second is R is inversely proportional to the area of cross section of conductor. Other factors are nature of the material which is used and temperature. When temperature will increase, in that case also resistance will increase. 2 points we got: R proportional to L and R proportional to 1 upon A. If we'll mix these two, then R is proportional to L upon A. To remove the sign of proportionality, we can use constant, that is rho. So R equal to rho L upon A. Here rho is a constant and it is known as resistivity of conductor. Rho is a specific resistance or resistivity. Its SI unit is ohm per meter. Now what is definition of resistivity? Resistivity is resistance of a conductor of unit length and unit area of cross section. Means resistance of a conductor whose length is unit and area of cross section is also unit. SI unit of resistivity is ohm per meter. So what is resistance? Resistance is a property of a substance which oppose, which resist, which not allow flow the charges from one end to another end in conductor, means oppose the flow of current. Resistance is denoted by R. So R equal to V upon I, and SI unit of resistance is ohm. What is 1 ohm? If 1 volt potential difference, to produce 1 volt potential difference when 1 ampere current is flowing through a conductor, in that case resistance of conductor will be 1 ohm. Suppose it is asked, define 1 ohm resistance. So what is 1 ohm resistance? 1 ohm resistance is the amount of resistance which is required when 1 volt potential difference across the end of conductor and 1 ampere current is flowing through the conductor. In that case, amount of resistance will be 1 ohm. Resistance depends on the length of conductor. It depends on the area of cross section of conductor, nature of conductor, and temperature. Resistors in series. Next topic is combination, connection, arrangement of resistors in series. Two or more than two resistors are connected one after the other such that same current flow through each conductor when some potential difference is applied across the combination. If we are taking three resistors with resistance R1, R2 and R3 and which are connected in series. Here in figure, three resistors are taken. Resistance of first is R1, resistance of second is R2 and resistance of third is R3. These are connected such that these are connected one after the other. Initial terminal of first and another terminal is connected with first terminal of second. So these are connected one after the other, and this combination is known as resistors are in series. Suppose when we'll put key, we'll switch on. In that case, current will start to flow from the battery. When this amount of current flow from first resistance R1, in that case potential difference will be V1. After that, same amount of current will flow from R2. In that case, potential difference will be V2. Then current is flowing from R3 and corresponding potential difference will be V3. This way, current again reaches to the same thing. If two or more than two resistors are connected such that they are one after the other, in that case, this combination is known as resistors in series. In circuit diagram, we have shown R1, R2, R3, three resistances are there. Only one path is there to flow the current, so current will not change. Only potential difference will distribute. If V1, V2, V3 is the potential difference between or potential difference across R1, R2 and R3, in that case V equal to V1 plus V2 plus V3. We know that according Ohm's law, V equal to IR. In that case, in place of V, we can put IR. In place of V1, we can put IR1. In place of V2, IR2. and V3 is replaced by IR3. In this step, left hand side will remain as it is, IR. From right hand side we will take I common. From both the side I will cancel and R equal to R1 plus R2 plus R3, means equivalent resistance will be equal to the sum of resistances which are connected in series. Now, if resistors are connected in parallel, so what is meaning of parallel? If two or more resistors are connected such that one end of each resistor is connected at one common point and other end of each resistor is connected to other common end point, means one end of all the resistors connected at one common point and other ends of all resistors connected at common point. For example, in figure you can see X is a point where first end of R1, R2 and R3 connected. Y is another point where other end of all conductors are connected. So two or more resistors are connected such that one end of each conductor is at one common point and other ends of these resistors connected at other common point. According circuit diagram, X, Y is a conductor, R1, R2 and R3, three resistors are taken. They are connected in parallel. In this case, potential difference will remain same. To measure it, voltmeter is connected. To flow the charge, to flow the current, battery is connected, key and ammeter. When we'll place key, current will start to flow from battery and after reaching to point X, it will distribute because there are three paths to flow the current. So I will divide into I1, I2 and I3. I1 is the amount of current which is flowing from resistance R1. I2 is the amount of current which is flowing from resistance R2 and I3 is the amount of current which is flowing from resistor or resistance R3. After that, from point Y, this amount of current I will flow and that we can measure in ammeter. So here current is divided into I1, I2 and I3 which flow from R1, R2 and R3. So I is the amount of current which is divided into I1, I2 and I3. According to Ohm's law, we know that V equal to I into R. In place of I, we can write V upon R. So I will be replaced by V upon R. I1 will be replaced by V upon R1. I2 replaced by V upon R2 and I3 replaced by V upon R3. Left hand side will remain as it is, V upon R. From right side we will take common V. In bracket it will remain 1 upon R1, 1 upon R2, 1 upon R3. From both the sides, from left and right, we can cancel, we can cut V. Then remaining is 1 upon R equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. It means equivalent resistance is 1 upon R equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. So in this video we have discussed what is resistance, what is resistivity, arrangement of resistors in series and parallel. In next video, question based on combination of resistors will be explained. Thank you.